Alright, hello, this is Wallaber, and we are back working on my little mini sort of fun side project here, which is this game that I want to integrate in with Twitch chat. Quick recap, the game is going to be sort of like a pachinko or pinball style game. It will sort of sit in a section of this tall, narrow section of the stream, and a ball will be bouncing down, and chat is going to be guessing which bucket it's going to fall into in the bottom of the board, and trying to get a high score by consecutively guessing the correct bucket and guessing earlier than other players. So we made some pretty good progress so far. We have like a really rudimentary way where we can lay out little boards. I have a little temporary pinball type object here, and if I hit play, you can see over in the right here we get some graphics, and we get the ball bounces and rolls around and falls down through the level. So definitely lots of things that I can improve, but I'm happy enough with this to keep moving forward with the logic of the game. So I think the next thing that we're going to do is get it to build the little buckets at the bottom. And so we already have this script called level board over here, and it already has some properties I've defined that you can tweak, like how many buckets are there and how wide are the dividers for the buckets and how high are they from the bottom of the level. So we should use this to generate those colliders first off. So we're going to go to this script, which does a bunch of stuff right here. See, so on start, we're creating colliders and visuals for the frame of the level. And then so now down here, we can be like, create the buckets. And we're ultimately going to need to create the colliders that separate them, as well as triggers to detect when the ball has actually entered in. And that makes me realize that we're probably going to want, in addition to this, we're going to want a thing called private float bucket trigger inset, which is basically how much lower is the top of the trigger going to be than the actual separating colliders. Because as soon as the ball touches the trigger, we want to be convinced that the ball is going to fall into that bucket. Okay, so now we need to go about generating these. So this should be pretty simple. So we're going to split up this space into, well, we just basically need a loop. I guess we're going to put a check in here to make sure that the number of buckets is reasonable. This is something where we could just say, well, just don't pick an unreasonable value, but we might as well try and be cool here and make it smart. So I think the way that we can do that, let me bring this up a little bit so I prevent myself from dropping down here and putting the code down behind the overlay. Okay, so right now we're going to say bucket, final bucket count equals the authored value bucket count. Okay, and then we say, let's see, bucket space, what are we going to call this? Bucket space width. Okay, and we need to calculate this. So let's think about this. We're gonna make, oh, I gotta get myself back into somewhere where I can draw a doodle here real quick. Okay, so okay. Loading. I think. Okay. So we need to make sure we get this math correct, because we have to take into account the width of the colliders that are going to separate the buckets. We also have an inset value that we set for the edges of the frame, so we need to take all this into consideration. So This is going to be easiest if we draw a little picture. And I'm just filling time here as I try to actually get Photoshop to launch and be in a usable state. Okay. Almost there. We're very close to having Photoshop. Okay. Come on. Oof. I feel like my computer has been chugging lately, and I may need to do some cleaning. Everything seems to be taking longer than it's supposed to. Alright. So. Alright. So we've got the actual level, right? But we need to take into consideration that we have this thing called frame collider inset, which is how far in from the edge is the actual collider. Okay, so there's some collider inset here. So to start off, this empty space that we have right here is going to be width minus 2 times inset. Okay, so we're going to need to think about that. Then let's say we have 3 buckets, so then we're going to have 2 dividers. Whoa, 2 dividers like this. Okay, and so then the space here, what have we got? We need to, so we also need to essentially subtract out this component here, right? So we need to take this whole thing, and then we need to subtract buckets minus 1 times the bucket collider thickness. Okay, so that's going to give us the space we have to work with, and then we're going to divide this whole thing by buckets. And that should give us what we're looking for. That should give us this size here, which is W, which is SW, space width, right? And that is this formula here. Okay, so let's go here and let's start calculating this out. So we're going to say float frame space width, right, is equal to the rect dot size dot x minus the inset times 2.0f. Okay, and then we're going to say frame space width minus equals bucket divider width times bucket count minus 1. Okay, so then we can say bucket space width is equal to frame space width divided by, thinking about this in terms of a float, bucket count. Okay, and then I guess what we want to do is we want to say if, I don't know how much padding we should give it, but we'll say like a float, safe size is equal to, I guess we need to know about the radius of the ball in order to calculate this properly, which we don't currently have a reference to here. Maybe we could just go like this and say, we'll put a script on it. So this is the ball prefab reference. Okay, so we're going to make a new script back in Unity. Okay, we're going to make a new script called ball. Okay, and ball is going to have a reference to private, what is it? It's a circle collider 2D. Okay. And so then it's going to have a public float radius that you can get, and that's just going to return the collider's radius. Okay. So now that we have that back here on the board, we should be able to say, okay, a safe size would be ball prefab ref.radius plus, I don't know, 0.5 or something. And then this, we should actually be calculating this up here. Okay. And what we probably actually want to do is do this while and we're gonna say, okay, so what do? We go in here, we say, okay, well, we don't actually need this. We say how much space do we have, and then how big is a bucket thing, and then we would say, no, I guess, I don't know if a do while is a good one. I guess we could say, yeah, because where do we do our increment? Okay, let me think about this. What I want to do is I want to put this in a loop that will keep trying until it gets a size that works, right? Because what this will do is, then what we want to do is right here we want to say if bucket space width is greater than or equal to safe size, we're done, right? So this would be some kind of a break. So I guess we could just do that. We could say, up here we could say like float bucket space width equals, and we'll just set it to 0. And then we can say here, while bucket space width is less than or equal to safe size, we do this loop. And then I guess we don't even really need to do this. We could just do this, I think. No, sorry. We want to do it like this. Like this. Okay. So we'll break out of the loop there if we're happy. Otherwise, we're about to do another iteration, and so we're going to say bucket count minus minus. Or bucket count minus minus if bucket count equals 0, break, and we would be like debug.log error could not find reasonable bucket count. This shouldn't happen, but I guess if you like set the radius of the ball super huge, we want to at least try and handle this. Okay, so how does this work? We figure out how big we need the spacing of the buckets to be at its absolute smallest, which is going to be this. And this number probably shouldn't be hard-coded. We could put it up here. Let's put it up here, right? So we'll say like, let's put it in with the bucket stuff. Whoops. Okay. We're going to serialize another field called private float bucket minimum gap around ball. Okay. So that number is this. So we say, okay, the space in a bucket needs to be at least this big. So then we say currently our space is 0. We got no space at all. So let's work on this. We get into this loop. This loop says, okay, this number is never not changing. I can put this up here. Okay. And I can put this up here. This is all just calculating the amount of space we have, which is not changing. Wait, yes it is. It's changing based on bucket count. What am I talking about? This has to be in the loop. Okay. So we work out how much space we have based on the current bucket count value. And then we calculate, okay, well, how big would that be? And if it's big enough, we break out. And the current bucket count is acceptable, whatever it is. If it's not, then we need fewer buckets, so we try to decrement that. But if we make our way all the way down to 0, we don't know what's going on, and we got to get out of here. Okay, so now that we can actually make the actual buckets. Okay. Now, spacing wise, now we're about to have to do some math that says where is this position and where is this position. And what those should be is equal let me think about this. Is this equal space from here? Well, yeah, we want, yeah. We can recalculate this, or actually have this bucket space width. By the time we hit this spot, we have a correct value for bucket space width, which is this. So what we want to do is we want to start here. We want to walk over bucket space width plus half of a thickness, and that's where one goes. And then we want to walk half of a thickness, bucket space width, half of a thickness, and put where this one goes. And repeat. Well, until the last one. But you don't care about this space here because it's a leftover as a result of this. Okay. Alright. Doop, doop, place, and then skip. Alright. So now we're going to say for int I equals 0, I is less than buckets. Bucket count minus 1, right? Because we only want to go... this is 3 buckets, but we only need 2 iterations of this loop. Okay, so, and we're going to start, we're going to say float x, let's see, we're going to make a vector3 called current position, okay, and it's going to start at, where are we positioning some of this stuff up here? This is the level board itself. Okay. So our coordinate space is, take a look at the board, right? Our coordinate space is that our origin is in the bottom left. Okay. So that means that our starting position here is going to be inset, the frame collider inset, and we're going to be halfway up of the bucket height. Okay, so this is going to be bucket height times 0.5f and no offset on the z. Okay, so that's where we start. Then our rule here is we need to move over bucket space width plus half of bucket collider thickness. Okay, so we'll do cur pos dot x plus equals bucket space width plus bucket divider width times 0.5f. Now some of this stuff, like I could like pre-multiply this and not do it inside each loop, but it's really not going to matter. So might as well just like make it super explicit what the math is. Okay. And then this is where we need to create the bucket divider collider. So we're gonna make a game object for this. Div obj equals new game object, and we're gonna call this bucket divider, and we might as well put I in there. Why not? Okay. Div obj transform set parent to this transform. Okay, and then div obj dot local transform dot local position is equal to current pos. Okay. Then down here, move over another half divider width. So cur pos dot x plus equals bucket divider width times 0.5f. Okay. All right, now let's give this a collider. So we're going to have a box collider 2D, right? This is the div call. So this is, you go to div obj, we say add a component called box collider 2D, please. And then we say div call dot size is equal to, and this is going to be the divider width, and this is going to be the bucket height. Okay. And then let's give it some visuals as well, which we can just put right on the same game object. So we're gonna do shapes dot what do we want? Rectangle. Visrect equals divobj dot add component of shapes dot rectangle. Okay, and then visrect dot size, what is it, width equals bucket divider width, and visrect dot height equals bucket height. Okay, now this has no like controls over the appearance of it yet, but let's just see if this code even does anything proper, or what sort of funny business we have caused for ourselves. So we need the ball to have, let's go into the prefab itself and let's give this the ball component, move that up to the top and give it a reference to its collider, go like that. Now the board should get a reference to the prefab version of the ball, so that will always work. It's not the one in the scene. Okay, let's run it. Okay, look at that. So we generated colliders, and here they are. Only problem here is that this needs a sorting order. Okay. And so now this thing's going to bounce around, and of course in this case it keeps falling into there. Now, because I'm creating all this with script, it's going to be hard to do any kind of fancy setup on the look of this. So I think what we're gonna do instead is we're gonna say private shapes dot rectangle, and we're gonna say bucket divider visual prefab. Okay, this should be bucket minimum gap. Let's go find where I miscopied that right here. Okay, and then what we're going to do is, instead of this, we're going to instantiate a shapes.rectangle. And this is going to be from this prefab. So then we can say visrect dot, transform dot set parent to the div collider, like that. And then we can say visrect dot, I could have kept this in here, but that's okay. And then visrect dot height equals bucket height. Okay. And this needs to be divobj dot transform. Okay, so now what we can do, we can create a little prefab for what we want these dividers to look like. Now, right now everything looks similar because I'm just using like the same, just like, white rectangle at the moment, but maybe eventually this will look different. So this is going to be bucket divider visuals, or visual. Okay, and it's going to have a shapes rectangle on it. Okay, and that way we can say that it's a rounded rectangle with a 0.1 or whatever radius, and we could, just to confirm that this is working, it's going to be a can I put like a gradient or something on this? Maybe not. Oh, but here we can set the sorting layer. And this one should be high, actually, I think. And so we could say cool And just to test it, we'll make them like a yellowish color. Okay, let's make this into a prefab. Boom. And we can delete this one from the scene. And we can go here and we can notify it of this prefab. So now when we run this, we should be instantiating those. Okay, pretty close. Now the only problem is that we're not explicitly resetting the position. Local position equals vector 3.0. And might as well just be super careful here and say local rotation is reset and local scale as well. Okay. You waiting on me? Okay. All right, there we go. We got our dividers. And let's make sure the collision is working and everything by just testing out some different starting positions for the ball here, like right there. Okay, boom, boom, bink, 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 bink. Oh, this one really likes to settle to one side. Oh, look at that. Error. What's the deal with this one? This one is 1.4 units in from the edge. Oh, is that one? Interesting. This should be identically placed as far as distance from the edge. So do I have some difference here? That can definitely get wedged there. Can the ball get wedged over here? Yeah, it can. Okay. All right. So that means this needs to be negative 1.6 or something. Oh, right. This would be 1.6. I need to fix this because these aren't going to update now unless we do something dumb like we touch this for a second. I have to fix that. My way for authoring this with my little quasi layout system is perhaps lacking. Cool. Okay, let's actually make sure that we can collide with the bucket. I don't see why we wouldn't, but oh, that's not gonna do it. Right here. Dink, dink, dink. Oh, look at that. Now this is an issue. Because this collider is truly flat right here, this ball could actually come to a rest here. So we may need these to be different colliders. We may need them to have... What other kind of options do we have? We have a capsule. We could use capsule. Or we have to make it like... so if it's a capsule, it'll be like that. Which means that there's still technically a point there where the normal is straight up and down, and like something could sit right there on it. We could change it instead so that it's a polygon collider and it looks like this. Which might be the right choice. I guess we would just do it like that, right? So then we have to decide how to create these points. I assume that we would probably want this to be the bucket height. But we do already have. So probably what we could do is we could say, well, we know the width of the bucket, and so this distance from here to here to be a 45-degree angle would be like the divider width divided by 2. Okay, let's try that. So instead of a collider, this is going to be a polygon collider 2D. Okay. And then we're going to manually create these points here, which shouldn't be too bad. Let's see, set path 0 to a new vector2 list. And the first one's going to be, let's see, it's going to be negative bucket divider width times 0.5 f. And then we centered this thing, so we need to go down by the half bucket. I'll say negative bucket height times 0.5. Okay. Then the next point is over here, and then up bucket 5, or bucket height times 0.5, but minus bucket divider width times 0.5 f. Alternatively, you could manipulate gravity. Yeah, that's true. We could like detect the scenario where this is happening. This should make it a little more deterministic. Okay, now we want this to be 0. This is the center point. This is this point right here. So we just did this one and this one. And the center of our object is like right here. Now there's going to be over 0 and up just half. So over 0 and up just half of bucket height. Okay. Then we want one very similar to this, where we're over positive halfway, and we go up this same amount. And then we're going to want one very similar to this. You can kind of see the symmetry of the shape here, but where this one is positive. And this should have been negative, and this should have been negative. Okay. So, by the way, I just read hello. Okay. Well, let's have a look at this. Hopefully that line of code worked. Okay. Now can we look at the collider on this thing? Let's see, let's hide this. Yeah, there's our collider, so that's pretty solid. And that's going to really increase the likelihood that it always picks one side or the other. So we should be in good shape there now. All right. Okay. So let's get it generating the triggers down here. And maybe that's going to be the stopping point for today. Let's keep it kind of short today. I have my son waiting for me to play some Super Mario 3D All-Stars tonight, so I don't want to keep him waiting. I am for crazy wobbly obstacles. Yeah, so I mean this like layout I just made is not very interesting. You know, I think that this game will be most interesting when things like that don't happen, right? When it's a little bit more, you got a little more bounce and arc happening with the ball. You know, like if I drop it like this, maybe we'll probably get a pretty good rebound off the start, which would make it a little more interesting. Oh, well, maybe not. Maybe not in this case. Get it a little bit over to the side more. Which maybe is pointing out that these little walls that I'm generating also should have rounded edges. Like they actually probably should be capsule colliders. See there, that was cool. That was non-obvious where it was going to go. Like if I was, you know, locking in my bet right now, I'd probably say it's going to go in the center. Then you get that surprise rebound down there at the bottom, which is kind of fun. Yeah, I should change these the walls to be capsule colliders that have a rounded thing on them, and I could change the visuals to match that by making them a rounded rectangle where the radius is the half width, so that we get a capsule. You know, it would look like that. Oh, look at this, shape's this nice. It clamps it for you. Glorious. So that could be cool. That would probably be a good idea. Just to reduce some of the sort of surprising edges and stuff on things. All right, but let's get the triggers being placed, so that then next time, which I might have some more time this weekend to work on this. We'll see. We can start hooking up some logic to actually detect that the ball is landed, and then we need to do some recording of the ball and playback of the ball to make a more dramatic thing where we can control how long you get to decide your vote. And then we can start to get a sense for how this is really going to feel to play. All right, so in here, now here we're only looping. Right now we have like the edge of the thing, and if we have 3 buckets, then we make this piece, and we make this piece, and we're only doing 2 loops in this loop I'm in right now, but we also need to make 3 triggers. So what we could do here is we could change this like this, and what we could do is here we can move half of this. Okay, and then we're going to make the trigger, and then we're gonna come here and we're gonna move over the remaining and actually I think this guy needs to come at the end here. Needs to be here. Okay, so this would put us, because we're starting here, we can walk halfway, so we're ready to place our trigger here, then we'll walk halfway, and then a half step, then a half step and a halfway, boom, etc. And then that means that here, we only want to do this if I is less than bucket count minus 1. Since we're going to loop one more time here to make sure we can build the colliders. So like that. Okay, so let me just make sure that that loop still works properly. Oops, what did I miss? Okay, make sure this loop still works properly. Okay, and let's actually test this real quick. So what if we want 4 buckets? 4 should fit here, I think. Okay, it's happy with 4 because the ball can fit. And this is gonna go, where's this gonna go? This is gonna go right here. Oh, no, it was here. Okay, so we have good space there. Let's see if we try to push it to 5. Will 5 fit? 1, 2, 3, 4, 5. Yes, it will. And it's gonna go somewhere in the middle, right? Now I bet it goes right into the one to the left. Okay, try to push it to 6. It probably shouldn't let 6 happen. We should see 5 here. 1, 2, 3, 4, 5. Ooh, it believes 6 can do it. Let's see. Yep, okay. But if we change this, the bucket minimum gap to 1, I have a feeling 6 will not fit anymore. Yeah, it actually dropped down to 4, see? So that's cool. And if we set that back, right here, we set this back to 0.5, then it looks like we go up to 5. But we're going to have, I think for the most part, this game is probably going to want 3 buckets. Okay, cool. So that code is working properly. So now let's make the trigger. So bucket trigger object is a new game object. Bucket trigger, and we might as well do this whole thing where we know which one it is, so we can see things in the hierarchy view. Okay, and this bucket trigger object dot transform is going to be, its parent is going to be this transform, and this is going to be a box collider 2D. So that the trig collider is going to be bucket trigger object dot add component of a box collider 2D. Okay, and the trigger collider dot is trigger is going to be true. Okay. Oh, and we can right here. Bucket triggered object dot transform dot local position is equal to curpos. Okay. Then trig call dot size is gonna be what? It's gonna be bucket space width by, oh, and actually we have to offset the Y position of this slightly, because this is supposed to be bucket height minus, I guess it depends on the number of people in the chat how many buckets you want to have. Yeah, probably, right? If there's a lot of people in chat, then you kind of want to like spread and make it more interesting, or you just, maybe it depends on kind of how, like if you want it to be difficult or easy, you know, which is also related to the design of the little pachinko boards and how bouncy the ball is. If the ball's not very bouncy, this gets much easier. So that might be fun too. You could like maybe choose from different profiles, like tennis ball, you know, ping pong ball, you know, bowling ball or whatever. Not to change their size, but just to change their sort of bounciness. And then this is going to be frame bucket trigger inset. Okay, so this should generate them. Let's look and see. So we run this, and we got a trigger here. Yep, we got a trigger there. We got a trigger there. We got a trigger there. The only problem, see, is that they're centered and they need to be justified to the bottom of the board. So that's right here. So we're going to just subtract nothing from the X, but we're going to subtract inset times 0.5 from the Y and do nothing to the Z. Okay. And so that should give us what we're looking for here, which is that these triggers are now, yeah, bottom justified right here. See, so once the ball finally touches this trigger is when we're going to decide it's truly in this bucket. And we have a variable we can tweak, which is how far down they are inside there, which is this one right here, bucket trigger inset. So for example, if I set this to 2, we're going to see that these triggers are now like much lower. See, the ball has to get pretty meaningfully in here before we decide it did in fact go into that spot. Where's it going to go this time? Center. Nope, to the right. The ball's very bouncy. This is probably what? Basketball / ping pong ball level bounce. See if it does the same thing every time. Should be relatively deterministic. Yeah. Especially at the kind of scale and amount of collisions and stuff we're talking about here. But let's see if we just move it a tiny bit. Does it change it? Probably not much in this case. Oh yeah, actually that changed it significantly. Now it's going in the center. Cool. Okay. Probably want to put a little trail on the ball too, so you get a sense for its speed. Okay. So now we're in pretty good shape. In fact, maybe the last thing we're going to do is we're just going to add a script called bucket trigger. Okay. And this trigger object is going to want to know. Oops. Trigger object is going to want to know a couple things. First of all, it's going to need a reference to its. No, it doesn't need a reference to that. This thing is basically just going to have a void on trigger enter 2D. And that should pass in a collider 2D, which is the collider that entered the trigger. So we're gonna, is this the ball? So we just look for this script. Equals other dot get component. Just to be safe, we'll say in parent, in case later I decide to make the collider on the ball a child of the ball. So we're looking for a ball script on this object. If the ball script is non-null, notify. I would slightly shift or randomize the bounciness of the ball with every contact. Oh, that's interesting. Yeah, something we could definitely do. Maybe just that would basically just inject a little more randomness into it, right? One thing that's going to be randomized as well is the start position of the ball and the velocity of the ball coming in. My current plan is that when it leaves the board out the bottom, we're going to take that velocity, and that's going to be the starting position and velocity at the top of the next board, which should mean that, you know, because it's going to be randomized boards, that it's not like you see a board and you go, oh, I know this one, it always goes to the right. Because there's going to be this input randomness of the starting position and velocity and angular velocity spin of the ball. Okay, so these are going to have a public system.action, which is just going to pass in an integer for now. And this is on ball enter. Okay, and then these also need a private int bucket ID. Okay, and this is going to get a public int bucket ID, which you can set. I don't know why I'm doing a whole getter and setter in this particular case when it's just a plain old value, but I don't know, it's a habit. Okay, and then what we'll do here is we'll say if on ball enter is non-null, which it should be, but let's just be careful. On ball enter dot, just invoke this function with our bucket ID. Okay. And then what we can do is we can say on the level board, when we create the trigger right here, we're also going to give it a trigger script. So this is going to be bucket trigger object dot add component of a bucket trigger. Okay. And this is going to get its on ball enter, subscribe to a function on this. So ball entered trigger, entered bucket. And we're also going to tell this one what bucket it is, and that's easy enough because this is the bucket ID is I. So the leftmost one is 0, 1, 2, 3, and up to bucket count -1. And then we need to define this function. So let's put that down here. Okay. And let's just print it out for now. Ball entered bucket. And let's just do this. And we could actually do something kind of fun here, just to test this. Just for fun. This is not going to be the final design. Let's do this. Private Twitch client. And then what we can do is down here is let's actually say this in chat. So we'll be like if client is non-null, client dot send message, not send message. What is it? Client dot. Oh, we're not. No, client dot send message. There we go. And this is going to be, this is kind of gross looking, but client dot joined channels 0. And then we're going to say bucket plus bucket ID plus is the winner. Okay. Okay, so let's test this out. So now we just need to give the Twitch board a reference to the client, which later we're gonna do this differently. But now in theory, when we run this, the ball will go in here. It will touch a trigger. And look at that, showed up in the Twitch chat. Bucket 1. Yes! Sweet. Okay, let's try it again. Let's start it right there. What's this one going to be? 0, 1, or 2? I think it's going to be nothing, because it's going to sit and bounce forever. Little nudge. There we go. Okay, this is going to be 2. Nope, it was 1. Bucket 1 is the winner. Let's see, let's try coming at the center, but we're going to collide with it off to the side. 0, 1, or 2. Oh, 2. Okay. Definitely need to delay. Oh yeah, it's not even going to say it like this. So next time, now we can start building the actual kind of sequencing to this. Because the way it's going to work is it's not going to show the ball in real time. Behind the scenes, it's going to step the physics really fast and actually go until that callback happens, so that now the game knows, oh, it goes into bucket 2 or whatever. And also, while it was stepping the physics, it's going to be recording the position of the ball the whole way. All this will be happening in the background. You won't see that. And then it's going to go into this state where it plays back a portion of the ball's trajectory and then repeats it, and giving you time to put in your vote at some score number. Like this is worth 1,000 points right now. Then it'll be like, okay, fine. Now it's worth 800 points, and it will show you a little more. Show you a little more. Show you a little more. And then it'll be like, okay, now it's 500 points, and it'll show you a little more. Show you a little more. And what I'm going to do is I'm going to take the whole playback, because we know how many steps it took, and we're going to divide that up into chunks and say, okay, this first chunk, if you can guess it just with this much information, you get this many points, this many. And then as it's falling and doing that would be the time that chat has to actually put their predictions in. And then when it hits, once it's shown the final one, it will finally go into reveal mode. It will basically cut off voting, and any commands that come in after that point will be thrown away. And then it will reveal the full path. And then it will do a thing where it recaps who got what points and stuff. And then the screen will scroll up to the next board and continue. That's the current idea. We'll see how that works in practice. So the main things we got to do next is we have to actually do that thing where we record the ball and then display back the subsections of that replay. And then get that working, and then we can actually test it and get in the part where if you type in a chat thing, we at least remember what you said. And then, when it goes in, we could just debug print out who got it right or who didn't or something until we can start hooking up some kind of a visual scoring scene, scoring recap or something. So that's good. That's good progress. That was roughly an hour today, and we got the dynamic bucket generation working. We've got the colliders being created. We got the triggers. The triggers are detecting the ball, and we even just threw in a quick debug chat message, which is always fun to see that this thing is actually connecting to chat. So yeah, I think next time I work on this, I'll try to find when I have maybe more than an hour in one go, because I'd like to get to where the core states work, where it's okay, simulating under the hood, revealing and taking in votes, showing the answer, doing some kind of recap, load a board, repeat. If we can get all that in, shouldn't be that bad. Then we'll be at a point where now we can actually play it and start to iterate on it and think about things like the size of the ball, how bouncy is it, what should these boards look like, stuff like that. But yeah, so pretty good start, pretty happy. And I'm going to stop for the day, go play some video games with my children. Yeah, thanks for hanging out, and I'll be back maybe sometime this weekend. If I stream again this weekend, it will probably be working on this. I do have some Pro Gymnast stuff to do as well, but it's not super interesting, so I'll probably do it off stream. And yeah, thanks again. See you later.